thanks again, Reid, for agreeing to do this interview for the people at the University of Waterloo. It is going to be valuable for them. You clearly have a strong background in this area. You've written and you advise widely on artificial intelligence, and particularly the ethics of that in the world. So you're described as a speaker, advisor, and ethicist. And I was wondering, first of all, how your career led you into this role.
A series of bad decisions, I think. So, I didn't think that I would be here. It certainly wasn't part of the grand plan to the extent that I had one. I was obsessed with philosophy as an undergraduate, which led to my ultimately getting a Ph.D. in philosophy with the aim of becoming a professor. I did all those things. I was a professor for 10 years. During the course of when I was a professor, there was an entrepreneurship organ. Sorry, I'll back up just a little bit. In graduate school, I started a fireworks wholesaling business. As a grad student, as you probably know, you don't make a lot of money. I started this business. It went quite well. It actually still exists. I don't run it anymore, but I'm very, very involved in the, I'm very much involved on the, I'm involved in the very much the fringes. I'm not sure where to put the very, but I'm barely involved. That's the line. Anyway, the reason that's relevant is that it explains how I came to mentor students who had startups as part of an entrepreneurship organization at the university at which I was a professor. This is Colgate University. And I was looking around at these students doing all these cool new things, and I thought, I want to do something cool and new, but what would that be? Well, I love philosophy still. And I always specialized in ethics. I don't know what that would look like. I don't want to leave that really, but I would want to do something new. What would that be? The only thing I could think of at the time was an ethics consultancy. But then I thought, well, what's the market for that? And I didn't think, and I think I was right for the most part, there is not a market for that. But then Cambridge Analytica happened, the Me Too movement, Black Lives Matter, lots of stirs and rumblings about Gen Xers and not Gen Xers, Gen Zers wanting more meaningful work, getting sick of companies prioritizing profits over people. And once I heard all that stuff, then I thought, okay, there's a market there for this. And then you combine that with various sort of, I don't know, personal or, not non-career issues. Like my wife's career was based in Manhattan. I was a professor in upstate New York. We were going back and forth. We were having a second kid. Wasn't a huge fan of my department. Frankly, two of my closest friends, one got denied tenure, one was anticipating and getting denied. So my best friends had left. So you sort of put the fact that I've been waiting for a market around ethics consulting to emerge or possibly for there to be a market, plus those sort of personal or social considerations, they sort of merged at the same time, and it just made sense. I think there's a business here, and it's super interesting. So off I went.
Makes sense, and it's been very successful, but it has also included you being a writer, and your most recent book, Ethical Machines, includes a quote that I thought was very interesting. It's a quote that's used to promote the book, but it basically said that AI products, artificial intelligence products, are a bit like circus tigers. You raise them like they're your own, you train them carefully, they perform beautifully in show after show, and then one day they bite your head off. And so that implies that there's something we should be worried about with AI. And so I wondered, why should we be worried about AI?
So, okay. Yeah, I like that quote a lot too. I mean, I'm the one who pulled it out to market it with that quote. My editor actually at one point wrote, "Is this offensive to Siegfried and Roy?" And I just said, "I don't know, but I don't think I care. Because it's true and funny." So what interests me about I'm going to broaden the question a bit, not just about AI, but what interests me about digital technologies and ethics, that intersection, is not any kind of, if you like, conceptual claim about, there's digital ethics over here and there's, regular ethics over there. That's not, if you sort of carve up the conceptual space, that's not how things go. You could just have, ethics, and then there's ethics applied as it applies to, possibility of euthanasia, possibility of abortion, AI, blockchain, whatever. You could just say there's ethics, and then we apply to these different things. I think what's interesting about the category of digital ethics, and AI ethics is of course a subset of that, is that it's by virtue of how these technologies work, including AI, that makes it the case that certain kinds of ethical risks are likely to be realized. So let me contrast that with, say, a screwdriver. You build a screwdriver, you're not increasing the likelihood that someone's going to build a concentration camp or a home for the homeless, right? There's nothing about the screwdriver itself that increases the probability that one thing happens or another. But what's interesting about a lot of the new technologies, including especially AI or machine learning, and I'm using those interchangeably, is that it's the nature of the beast. It's how the thing works that increases the likelihood of things like discriminating against people based on race, gender, ethnicity. It's the nature of the beast. It's how AI works that we wind up with outputs or decisions that we can't explain. And it's the nature of the thing to make certain kinds of predictions about people, where those predictions are one way, among others, that you can violate people's privacy. So those big three risks, I call them the big three, they are likely to be realized just because of how or what the tool that is machine learning is. You don't get that with screwdrivers, you get that with AI. I think you also get it to some extent with blockchain, with quantum, with AR, VR. Different kinds of concerns arise in those cases, but it's the nature of the beast to increase the likelihood of those things. So that's what I find interesting about, sort of, I don't know if it's philosophically interesting or intellectually interesting, but also sort of pragmatically interesting. If you're in the business of mitigating these risks, then it's helpful to know, oh, these are the ones that we really need to look out for given how the technology works. So did I answer your question?
Yeah, I think so. I think what you're saying is the technology has the ability to produce unintended outcomes, whereas with a screwdriver, someone has to actually turn the screwdriver or do whatever they choose to do with it. And the human has a decision-making capability about that. Whereas with the technology you've described, the technology itself can do things that have an outcome that was not intended by the creator or the human that is in control of that technology.
Yeah, I mean, that's part of it. It's certainly the case that you could have unintended consequences with a screwdriver, right? So maybe this person invented the screwdriver, whoever that was, and they just never thought, oh, maybe people are going to build bombs with this or whatever. Right? That's an unintended consequence of building screwdrivers. Okay, and among other things, among other tools as well. It's not merely that there are unintended consequences of this technology. It's at least two things. One of which you just drew attention to, which is that usually the ethics of the action, whether it's right or wrong, or ethically permissible or impermissible, or at least are not, if you like, dictated by the tool, but usually it's by the intentions of the actor. So putting unintentional consequences to the side, I'm intending to make a bomb. I'm intending to make a guillotine, whatever one is making. But there are certain kinds of ethical decisions that are embedded in machine learning models that the designer or designers likely don't know that they're making it. And very often the user of that tool doesn't know that they're dealing with some kind of ethically charged tool here. For instance, the HR hiring manager doesn't know that they're using a biased algorithm or a biased model to vet the resumes that they get, right? So it's got nothing to do with the intentions of the user of that tool. That HR manager's intentions are neither here nor there as regards the discriminatory impact.
Yeah,
that's one issue. The second issue is just the increased probability. So there's, if you like, the set of all ethical risks. There's tons of them, right? Failing to respect someone's dignity, violating human rights, lying to them, breaking a promise, blah, blah, blah. There's just, thousands of ways you can ethically go sideways. The point that I'm making about digital technologies, or at least some of them, and definitely about AI, is that among the set of ethical risks that there's a certain subset of them that are likely to be realized. The probability of those risks being realized is increased by virtue of how the technology itself works. That's not the case with the screwdriver. It's not the case that it's because a screwdriver works the way that it does that it increases the probability of doing something ethically bad. That's not, but that is the case with machine learning.
Which suggests that we need to be more cautious and more conscious about what we're doing with AI than we might need to be with a screwdriver in order to ensure that we do good things. And that leads me to the next question, maybe, which is that you've said that organizations' attitude to AI should be based on not bad rather than good. And I think I understand what you mean by that, but maybe you could explain it for the people who are watching.
Yeah, there's a lot of people in the AI ethics space who talk about, we're for AI ethics. We care about AI ethics. We care about responsible use of AI. We want to make sure that AI benefits everyone and has a positive social impact. And I sort of think that's all great. It sounds lovely. It doesn't speak to my audience. And my audience is primarily, anyway, leaders in business. Leaders in business, they may very well care in some way about positive social impact, making the world a better place, benefiting everyone, blah, 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 and all the other, catchphrases that sound lovely and make you seem like a great person. But that doesn't mean that they're going to spend money on it. That doesn't mean that it fits into the daily operations of a business. Positive social impact, a business can do that, but usually it's not part of their core business model. It's just an add-on thing like corporate social responsibility. They have a nonprofit wing, and that's how they have positive social impact. But day in, day out operations that sustain the business, you're not thinking about positive social impact, you're thinking about the bottom line. And so I don't think that the language of, so I call all those people who want to have positive social impact, that's if you like, the explicit goal of the use of the AI. That's a small subset of use cases, and it's not the kind of thing that's going to move business to adopt AI ethics practices. What businesses need to focus on, in my estimation, is just not ethically screwing up. So it's one thing to do good in the world, and great, you should do good, obviously. But ethical rule number one, and in fact, business rule, marketing, branding rule number one, first, do no harm. Right? So just don't do what you're going to do. This is my view anyway, about this is what AI for not bad is. Do what you're going to do in your business using AI. Use the tool. Pursue your normal business objectives of, whatever it is, maximizing shareholder value or turning a profit or whatever it is. That's fine, all else equal. Just don't do it in a way that's ethically dangerous. Don't put people and society at risk in pursuit of those goals. So don't do bad stuff. And so that's what AI for not bad is. It's pursue whatever your goals are, presuming that the goals are not intrinsically ethically objectionable. So they're either ethically neutral or ethically good. And make sure that the means to those ends don't put your company at a high risk, or at least at an unacceptable risk, let's say, of wronging people.
Sure. So companies do lots of different things. Some of them create good in the world. And some companies more than most, some companies less than others. Yeah. But the important thing, but they also do other things that aren't contributing to good, but at the same time are things that are good for that company to do from their own performance or profit point of view, and are not having a negative impact on society. They're good, but just make sure when you're applying technology, in this case AI, that it's not doing bad in the world. That seems good. Right.
If you're Nike, you're selling shoes.
Sure.
Fine, great. Nothing wrong with that. People need shoes. I don't think that Nike deserves any great moral praise for the things that they sell. Yeah. But they certainly don't deserve any kind of moral condemnation for selling shoes and sweatshirts and sports gear or whatever. So go ahead, do what you're going to do. Sell your shoes. And when you're going to use AI to market that stuff, don't do it in a discriminatory fashion. That seems like a relatively low bar.
Okay, so your comment on the discriminatory fashion comes on to my next question, which is around bias in AI. We've heard a lot about it, and you've talked about the challenges of it and provided some guidance on how we should deal with it. So what is that guidance? What should we do about bias?
Well, okay, there's not the thing to do. There's lots of things to do. So there's sort of two questions at least. One is, what are the sources of bias? With an emphasis on the S and the second S in sources. There's many sources, not the one. What are the sources of bias? And then what are the appropriate bias mitigation strategies and tactics? So that's the second question. The go-to explanation for bias or discriminatory models is that there's a problem with the training data. So one example that people like to use is things like facial recognition software, which was years ago shown to be discriminatory against or biased against people with darker skin, especially women with darker skin. And why is that? Well, it's because the training data sets, the examples that they used to train the AI weren't sufficiently diverse. They didn't have enough data about, say, what Black women look like in photos, not enough angles, not enough varied lighting conditions. And so it was really bad at recognizing Black women. And so what you'll hear a lot in conversations about sources of bias is it's the training data. There's a problem with the training data. The training data is biased in that it's not what, and so what we need, and comes to the bias mitigation strategic question. We need representative data sets. We need data sets that represent each of the varied kinds of people that there are, or something along those lines. Excuse me. And that's true for, in a way. It's just not the only source of bias. There's lots of sources of bias, or lots of sources of discriminatory output. Part of that is because there's a number of ways or a number of reasons why you get the AI outputs that you do. Yes, because your training data is what it is part of that explanation. You also, but another thing that explains why you get the outputs that you do is because of the way that you weighted various variables, those input things. There's the thresholds that you set, right? So, if someone's likely to default on their mortgage repayment at a rate of, 0.3, then they get rejected. Anything below that, they get approved, whatever the number is, I don't know. Where you set your threshold is going to impact what your outputs look like, what your objective function is, what you're trying to maximize. That's going to affect, of course, what your outputs look like. So there are as many sources of bias as there are determinants of outputs. So anything that can impact what the outputs look like can be a source of bias. Similarly, any appropriate or effective bias mitigation strategy can target any one of those things. So maybe the appropriate bias mitigation strategy is getting more representative data. So for instance, more photos of Black women in different lighting conditions. Maybe it's not that. Maybe you got to adjust the weights of your variables. Maybe you have to adjust your threshold. Maybe you have to change your objective function. So there's lots there. Now, in terms of what you can do, at a very high level, it's kind of simple, which is before you even start training any models, when you're just in the concept phase, hey, do we think that AI would be a good solution here? Would it be effective? What might that look like? What kind of data might we need in order to make that happen? You can ask among all those questions at the concept phase, do we think that this data that we collect or what we're trying to achieve here could somehow or other result in discriminatory impacts? Right? You just start at the concept phase. Let's think about how we might wind up with discriminatory impacts. And that might affect how you collect data. We could get, data from, such and such police departments, but these police departments tend to historically over-police Black neighborhoods than white neighborhoods, and so we're going to get skewed data somehow that way. We're going to get so maybe we want a different source of data. I don't even have the use case in mind. I'm just saying if you just think about how we might wind up with discriminatory outputs, that's going to affect how you collect data, what threshold you might set, maybe how you weight the variables, so on and so forth. So the first thing to do is think about it at the concept phase, but then you have to think about it at each stage. You need to think about these things at each stage of the life cycle, because at each stage of the life cycle, you're making various kinds of decisions that will ultimately have an impact on what your outputs look like.
Well, sounds like good advice, very practical, step by step that people should look at as they're working with AI. There are a number of areas that they need to look at, and possibly more than the ones that you've mentioned, but the idea that they should be considering at every aspect of what they do with AI, how bias might come into that, and what they should do about it. It seems like good advice.
Yeah, and let me give you one more sort of bit here. You might also want to make sure that you're not using data that using that data constitutes a violation of someone's privacy, training data. Yeah. So, one reason why the stage thing is important, sequencing of the inquiry could be really important, is that you might get a bunch of data, you train your model, things look pretty good from a bias perspective. You later learn, maybe your risk department says, actually, you can't use that data to train the model. And so then you pull that data and you retrain your model. But now you got to retrain, you got to retest for bias. because now you're using different data sets. So it's not something that ends. It's got to, every time you change something, especially big, like removing a whole data set from your training data, you have to check again. So it can't be like, we checked for bias, done. Now let's check for privacy. Oh, we need to make some adjustments there. Okay, we fixed the privacy issue. Now let's go on to next thing, right? No, you got to circle back now to the bias issue because you just messed up. You just played around with your training data, which could have impacted. Anyway, you see the point.
I do. It sounds like how we would deal with risk in any type of environment, really. If we make a change in what we're doing, we've got to reassess the risk. And
absolutely,
that's really what you're saying about this. Makes total sense. Okay, you've also talked about explainable AI, and I thought I'd ask you to explain that, to say what you mean by that. But you've also talked about the need for transparency in AI, why that was important, and so what are these things and how can organizations do it?
Okay, so transparency and explainability often get lumped into the same bucket, which I think is unwise. So transparency, I think about, it's the extent to which the organization communicates different facts about the design, development, deployment of the AI, both internally and externally. So it's about the data collectors being transparent with the data scientists who are building the models, being transparent with the executives who approve deployment of the model. So one thing that transparency does is it's about internal communications, and it's about external communications as well, of course. So for instance, sort of a go-to example is being transparent with consumers that the chatbot, the sort of chat that they're having is not with a live person, it's with an AI, or being transparent with the public about, I don't know, sources of data where, there's different levels of specificity, of course, but what the basic sources are, what the intended use cases for the model, that sort of thing. So transparency is about communication, clear communication to both internal and external stakeholders. Explainability is a lot more specific than that. So you could think about, there's lots of decisions that lead up to training a model, lots, right? We're going to look into AI. We're going to use AI. We're going to use this data. We're going to set these thresholds. We're going to have this objective, or tons of decisions leading up to the training of the model. And then there's tons of decisions and communications to be had about after the model is trained. A model has inputs and it has outputs. Between the inputs and the outputs, what you have are the identification of really complicated, really complex mathematical patterns, right? So what a model is doing, or what an algorithm is doing when you're training up your model, or your software, or your model, or your algorithm, whatever you want to. People use these words in ways that sort of frustrate me because they're not precise. But anyway, like you don't have a biased algorithm, I don't think you have a biased model. Anyway, so you've got inputs and outputs. You've got the input. Your AI looks for some really, really complicated, typically mathematical pattern, especially if it's a deep neural network, looking for a really complicated mathematical pattern. And for instance, if this credit application matches the credit applications of all these other people who actually did pay back their mortgage, it gets a thumbs up. The output is thumbs up, approved for a mortgage. If, on the other hand, this new mortgage application instantiates a pattern that is had by all those people who defaulted on their mortgage, it gets a no, right? That's the output, no mortgage denied. So between the inputs and the outputs, there's a really complicated mathematical pattern that's being identified by the AI, and it can be so complicated that we can't understand it. We understand if you like the language in which it is, but it's too long. It's like, it's like when I try to read German words and it's just, they took 17 words and they shoved them all together into one word. I've lost track. That's the explainability problem. We can't explain how the output was arrived at. There's a difference between, I'll break it down slightly differently. There's global explainability and there's local explainability. Global explainability asks, what are the rules of the game that transform inputs to outputs? So what are the rules by which, say, mortgage applications to a university for admissions, applications for, not applications, let's do something else. Whether they should receive a certain kind of ad for, say, a house to buy versus a house to rent or something like that. Those are, what was I saying? Now I lost track. Those are really complicated mathematical patterns. And, oh, right. We want to know the rules by which decisions are made. how do we treat all such applications or whatever they are? Local explainability is what explains why this particular input got this particular output. What explains why Reid's application got denied, for instance? What explains why Peter's application got approved? So now we're not asking for if you like globally, what are the rules? We're asking locally, why did this particular input lead to this particular output? And because the explanations are so phenomenally mathematically complex, we can't really understand it. That's at least the explainability problem or the black box problem. And if it's just sort of like tagging photos of your dog, yes, this is your dog, no, this is not your dog, who cares if it's a black box? If it's this person has cancer or they're likely to develop diabetes in the next 2 years, or they shouldn't get a loan, they shouldn't be admitted to this university, now the stakes are a lot higher, and now we probably do care a lot about what explains why this person got accepted or rejected or diagnosed or didn't get diagnosed, et cetera.
That makes sense. And so in terms of what organizations should do with that, what should they do? Should they, presumably, I think what you're saying is that they should make that information more available to the people who might want to see it. Is it as simple as that, or?
No. So there's if you like two different kinds of models when we're talking in the concept of explainability. There's what it's called inherently interpretable models, and then there's post hoc explanations. And so inherently interpretable models mean you can look at it and you understand why the output is arrived at. So think about like a really simple decision tree, right? Are they over 45? If yes, go here. If no, go there. If do they have an income of at least $100,000 a year? If yes, approve for mortgage. Okay, we understand why. If no, deny. All right, we're done. We understand it. It's an inherently interpretable model. Other models are not inherently interpretable because they're just too complex mathematically. And then there are various kinds of techniques that data scientists employ to try to understand what's going on inside the black box. These are called post hoc explanations. They're explanations given after the fact that the model's been designed the way that it does, it operates the way that it does. And now we're trying to figure out with very sort of poking and prodding, if you like, to figure out what's making this thing tick, right? That's post hoc explanations. So the first thing that an organization has to do is come up with, devise standards by which their data scientists know, and not just their data scientists, but other executives, whether in this particular use case, whether an inherently interpretable model is required or not. If it is, okay, no deep learning. If it's not, if post hoc explanations are acceptable, okay, then do that. But now we have to start asking questions about, well, what constitutes a good post hoc explanation? How do we know that it's what are the standards by which we judge whether the post hoc explanation is an actual representation of what's going on in the black box model, or if it's a distortion? Because it's necessarily going to have to be a simplification, right? The whole point is that it's the complexity of the math that makes it impossible to understand. And so necessarily, whatever technique you use to explain what's going on must be a simplification. So then we ask, is that simplification simplified but still accurate, at least accurate enough, or is it simplified to the point of distortion? And then some things are going to trade on, want to know, well, in order to answer that question, you might ask things like, well, who needs the explanations? What do they need them for? How high are the stakes, right? Like in some relatively low stakes, you might not need, you can have explanations, you can have good explanations that are good enough. We're doing something that's relevant. Let's say we're doing, I don't know if this is a great example. Let's say we're doing fraud detection, right? So you've got a fraud detection agent working in the bank. The AI flags certain transactions as being potentially fraudulent, where there's some degree of explanation as to why it flagged this or that. The explanation needs to be okay, but at the end of the day, the fraud agent, him or herself, is going to do the investigation and make the judgment. So the explanations might be helpful. They need to be good enough to be helpful to the agent to do their investigation, but they don't have to be crystal clear. On the other hand, if you're a doctor and you're looking to figure out whether, the probability of this person developing diabetes in the next 2 years, and thus what kind of things you might prescribe or recommend to the patient, well, now the stakes are a lot higher. And so it might be, no, I need to know, I don't need just like something like what's probably good enough to give me an idea of what's going on, because the fraud, I need to really know if I'm to trust this thing. So, what's going to count as a good enough explanation will depend upon context.
And makes total sense, and also implies that the AI that you apply, the type of AI that you use, would depend on what you required in terms of explainability. That seems to be what you're saying. We would make that decision before we started to design and create an AI tool of some kind.
Right. I mean, imagine you don't make that decision, right?
Yeah.
And you're like, you know what? We're just going to make the most accurate model that we possibly can. In some cases, not all, but the default is supposed to be something like the more data we have, the more complex, the better. Because the whole appeal of AI is that it can see patterns that we can't. If it couldn't, then what do we need it for? And so someone makes it, and it's great, it's pretty accurate, but it turns out it's unusable by the end user because they need explanations. Right? So you make this amazing cancer diagnosing AI, for instance. It's more accurate than, let's say, at least the average doctor. It's more accurate than the average oncologist, even. Okay, maybe it's even more accurate than the best oncologists. Let's just stipulate. Nonetheless, and so you say, look at this amazing cancer identification tool that I made. Nonetheless, it might get into the hands of those oncologists, and they'll say, I get that it does really well on historical data, that it performs really well, in fact, better than me on historical data. But I don't know what's going on inside there. So I don't know if in this new case, this novel case with this patient that I'm seeing now, whether I should trust it or not. And since I don't know what's going on, yes, it's performed reliably in the past. I don't know if that means it's going to perform reliably in the future. I can't trust it, so I'm not going to use it. So you spent all this time building a great tool that no one will use.
Yeah. Okay. Now, a couple of minutes ago, you said that there was a difference between explainability and transparency, and I thought we should pick up on that and explore transparency. So,
sort of like I said earlier, transparency is about what you're communicating to various stakeholders. Explainability is about understanding what's going on between the inputs and the outputs. And you'll notice one way to pull these apart is that you can be transparent about the fact that you've got a black box, right? You can be transparent about the fact that you have no idea what's going on between the inputs and the outputs. You can also have a glass box, if you like. You have a complete explanation, but you don't tell anyone about the AI. You don't tell anybody about it, right? So in the first case, you've got high transparency, low explainability, because you're telling everyone that you've got a black box model. And the other case, you're not telling anyone, you're not being transparent, that you have a fully explainable model. So these things come apart. We know what's going on between the inputs and the outputs, but we keep it a secret. That's a lack of transparency.
Okay, so transparency is just telling people what you know and being open about what you know rather than not. Okay.
Yeah, that's right. I mean, I think that's exactly right. It gets more complicated because, look, you can be broadly speaking for transparency, but no one thinks, unless they're insane, there are probably such people should be transparent about everything all the time. Mm-hmm. That's not helpful. First of all, it would be just pragmatically unhelpful because you'd get too much stuff to look through so that you wouldn't know what is actually relevant and important.
Too much information.
That's right. But also, companies don't want to, they don't want to disclose reasonably enough. They don't want to disclose their IP, their intellectual property. So it's easy to say we're for transparency, but it's a lot harder to get specific about what that actually means. What are we going to be transparent about, to whom, when, so on and so forth. So you can be for transparency, but that doesn't mean that it's just obvious that you tell everyone all the things. You definitely shouldn't tell everyone all the things. That's a disaster.
Okay.
So there's a question about when is it appropriate to be transparent?
Okay, makes sense. So that leads, I think, reasonably nicely into privacy and the privacy implications of AI and how we should deal with those.
Okay, so there are at least, 3 ways that AI is connected to violations of privacy. The first one is with regards to training data. So you need a lot of data. Typically, you need a lot of data to train your AI. That data is often about people. And that just means that, and the possession of that data can itself constitute a violation of people's privacy if you've got your hands on data that people think you should not have your hands on. So AI, the fuel of AI is data, often people's data. And so organizations are highly incentivized to collect as much data as they can often about people. So in other words, they're incentivized, if they want to make their AI really robust, to collect data, the collection of which could constitute a violation of people's privacy. That's one way in which we get a connection between AI and machine learning in particular and potential violations of privacy. The second way is that it's of the nature of AI that whenever you're talking about people, you're making certain kinds of predictions about people. In other words, you are, if you like, inferring data about people. So you call that inferred data. You've got your training data, but then you've got your inferred data. And it could be the case that the possession of inferred data itself constitutes a violation of privacy. So for instance, suppose for the sake of argument, you've got some data about me. Let's say you've got two data sets. Let's say one of them is my geolocation throughout New York City, which is where I live. And let's assume for the sake of argument that it's not a violation of my privacy for you to have my geolocation. That'd be surprising, but let's just suppose it's cool that you've got my location. Let's also suppose that your second training data set is the addresses of therapists or cancer treatment centers throughout New York City. You put those two things together, you throw them into your algorithm, and it makes the prediction that Reid sees, goes to a cancer treatment center or sees a therapist every Wednesday at 3:30, whatever it is. That's inferred data. Arguably, that constitutes a violation of my privacy. So the two separate pieces of data that you had, neither have possession of those did not constitute a violation of my privacy, but the inference you made using AI based on that does itself constitute a violation of privacy. So that's another way. You're going to develop diabetes in 2 years, whatever it is. There's all sorts of predictions that one might make. So those can, you're pregnant, whatever. Those can constitute violations of people's privacy. The third way is really just use case specific. It just happens to be the fact that AI is used in a number of surveillance technologies. Most obviously, facial recognition software. And used inappropriately, which is very easy to do, you get violations of people's privacy by virtue of surveilling them in a way that is enabled by AI. So those are the three big ways: by virtue of the training data, by virtue of the inferred data, by virtue of the particular surveillance use case that you're applying AI to.
And your argument would be that we just shouldn't do those things. Is that right?
Well, there's context and context and context. Are you using facial recognition software to, on a general population because you're specifically looking for a child that's been kidnapped? Seems it doesn't seem to strike me as a crazy view to think that's ethically acceptable. Maybe it's not the right view. We're gonna have to. How big is the general population? Who's using it? What kind of authorization did they receive? Who's that data being trained with? There's lots and lots of questions to ask around it. But on the face of it, holding the kind of view that, hey, it's generally, in principle, okay to use facial recognition software on a general population. If you're looking for a child, on the condition that you're looking for a child that's been kidnapped, that seems like a reasonable, even if it's not correct, at least a reasonable ethical view. Are you using it? There's actually a really interesting case that came up recently that the New York Times reported on, which is that the owner of Madison Square Garden started using facial recognition technology at the entrance to Madison Square Garden. And it's supposed to, of course, be for security purposes, but what the owner is using it for is it's flagging anyone who works for a law firm that is in a legal battle with Madison Square Garden. So this woman recently was going to a Mariah Carey concert at Madison Square Garden. She was flagged by the facial recognition software. They asked for her ID. She is the person that the facial recognition software said. And they said, you can't come in. Reason being, they said it's a security thing. Real reason, she works for a law firm. She's not even involved in the case, but she works for a law firm that is suing Madison Square Garden. So she got booted. That's disturbing. A number of ways. So I think that there's horrendous uses for facial recognition. I mean, that's not even horrendous. That's just bad, not horrendous. There's, more horrendous would be like, using it to target the person that you want to murder. That would be worse. So there's, really bad and horrendous use cases for, say, surveillance technology. And there's, I think, ethically acceptable. It's going to depend upon what we're trying to accomplish, and why we're trying to accomplish it, and what controls exist to make sure that our use of it doesn't make it likely that things are going to go off the rails.
Okay, so one of the suggestions you've had has been that organizations should use AI ethics statements. as part of their way of appropriately dealing with AI ethics. Can you talk a little bit about those?
Yeah, so there's lots of AI ethics statements out there. They're mostly really bad. We're for fairness, we're for transparency, we're for explainability, we're for respecting people's right to privacy, and it just sort of stops there. Those kinds of statements, if they just leave it there, are useless. It's just PR fluff. That said, if they're written in the right way, I think they can do quite a bit. I think they can serve as the foundation for a general AI governance program, AI ethical risk program, whatever you want to call it. So if, for instance, I think that when people say we're for X, that has to be connected to something like 3 to 5, just pulling, something like that, 3 to 5 statements that are of the form, we will always X and we will never Y. So to give you an example, you say we respect people's privacy. I don't know what you mean by that. On the other hand, if you say we respect people's privacy, and that means we will never sell data about our consumers to a third party. Oh, okay. We will only sell aggregated and anonymized data about consumers to third parties. Okay, not as strong as we'll never sell, but I see that there's something that you're saying, you're connected to some guardrail of action. And we will always X, we will never Y specifies guardrails of action. We want to ensure, we want to do the best we can to make sure that we don't push out discriminatory models. And so we will vet all of our models for discriminatory impact, for the potential to create discriminatory impacts throughout the AI lifecycle. Right, that's a statement. You can water it down. We'll do it pre-deployment. We'll do it at the concept phase and at the deployment phase. We will involve stakeholders, external stakeholders, in the determination of what constitutes a discriminatory impact for this particular use case. Maybe you'll do that, maybe you won't. Right? The point is that if you specify your values, we're for privacy, we're for fairness, we're for explainability, we're for blah 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 blah. Let's say you got, let's just use an easy number. Let's say you got 5 of those, and then use another easy number. Attach 5. We will always X, we will never Y's to each one of those things. You've now got 25 guardrails of action. We'll always do this, we'll never do that. You can track that kind of thing, right? Within an organization, you can see, are we doing that? Are we making sure that we're always doing X? Are we making sure that we're never doing Y? Did we, we just pushed out, 10 models last quarter. Is it clear that we did a bias assessment throughout each of those models' life cycles? And there's going to be, you're going to want documentation, yada, yada, but if there's documentation, yes, we did all those things. That's not that's at the end of it, right? There's more things there's more things to do, more controls to put in place. There's lots of training to be done. There's tools to be used in order to pull off those, for instance, bias assessments. But it's funded by those initial statements. So I think value statements can be really helpful because they at least specify, when done right, they specify the guardrails. Beyond these lines, we don't pass. And again, it's not the end of the story, but it's a pretty good start.
Okay, so an ethics statement's valuable where it leads to particular action that would improve ethics behavior. And also, you've pointed out that being able to measure and assess that to ensure that that is actually taking place is also important.
Yeah. I mean, people want to know, what are the metrics? People say things like, how do we measure fairness? What are the metrics and KPIs for fairness?
Yeah.
And it's sort of like, no, there isn't. This doesn't work like that. You could have metrics regarding the kinds of things that you say you'll do in pursuit of that value, or what you'll do to live up to that value. If you don't say you're going to do anything, if you say we're for fairness, but we're not going to commit ourselves to any kind of actions, then there's nothing. Yeah, there's not much to measure. I mean, you can measure you can see like how many cases did we discriminate. I suppose you could do that retroactively. But otherwise, you can measure the kinds of actions that you've committed yourself to in relation to your ethical standards. And then, of course, there's going to be other things that undergird all that, like I think, like training your people, where you can't do good bias assessments if the people who are supposed to do the assessments lack the training and the skill, and if they lack the tools. So that's another thing you're going to look out for. Okay, we said we will always vet for bias in all of our models throughout the AI lifecycle. That's going to require training people. Did we give people that are responsible? Did we assign responsibilities, role-specific responsibilities to people in relation to bias assessment? Did we just say like, okay, we're going to do this? Or did we say, people who occupy this particular role will be responsible for engaging in in a bias assessment? And these people, this other role is responsible for ensuring that they've done that work, providing oversight, or giving an extra look over, or being the person that they consult with, etc. You're going to talk about RACI matrices, and that turned out to be really important for assigning role-specific responsibilities. So we know that if we're going to do bias mitigation, we're going to do it throughout the AI lifecycle. We better have a defined AI lifecycle. We better have role-specific responsibilities. We better have the tools that people need in order to do those bias assessments. And we know that we're going to need to train those people to understand their role-specific responsibilities and training to know how to use those tools effectively. Did we do those things? Again, that's all trackable. That's things that can be measured. Did we give any training to these people? We can measure things like, do they feel sufficiently prepared? Right? You give them a little survey. Do you feel that you've received sufficient training for you to be able to carry out your responsibilities well? If 80% say no, either they're all liars, or more likely your training's not very good. Better up the training, right?
Very valuable, good practical things for people to think about that are going to be working with AI, which many of the people who are watching this are taking an AI specialization as part of their engineering degrees or their computer science degrees. So that I think is going to be very, very helpful to them. We've also seen a growth in the use of citizen data scientists. You've looked at this as well. Can you talk about what why you think this has risks and opportunities, and what can be done about those?
Sorry, this is what's the risk?
You've talked about the use of citizen data science.
Oh, sorry, yeah, I missed that word. Yeah, right. So there's. I just missed the word citizen. So there's this thought that we want to democratize AI, which in this context means roughly something like we want to make AI available to more and more people, not just to the people with PhDs in physics who then did a fellowship to become data scientists, or just pretty typical. So we want to democratize it. How do we do that? Well, there are various kinds of tools, no-code AI or maybe low-code AI. Want to make it more accessible. And there's a certain sense in this. One thing is that data scientists occupy a very narrow specialty, and they might be really good at data scientists. They might be amazing at building models, but they might be really not very good at recognizing business opportunities. This is not what their training is in. They're trained physicists, or now and more, they're trained data scientists. So they might not be good at recognizing business problems. They might not be good at coming up with business solutions. They're really good model trainers. And so if an organization wants to have an effective AI strategy, you can't just have your data scientists saying, oh, here's what we can use AI for. You need trained up well enough business people in AI or machine learning to be able to spot, actually, I wonder if this is a good case for AI. I wonder if we can solve this problem with AI and solve this business problem, make a lot of money, blah, blah, blah. So that's good. And then if you can give those, then the thought is, if you can give those business people, if you like, those non-data scientists tools where they can start building some AI, because it's no-code AI, or low-code AI, that could be really valuable, because then we're not just dependent upon our data scientists to create these things, but we can have other people use AI and get really valuable insights using AI, and thus drive our business goals. So that's really appealing, and that makes a lot of sense. But there are various technical and ethical reasons to be wary. Technically speaking, it's just really hard. I mean, there's a reason why these people have PhDs and why they studied a lot to be able to do data science well, because it's a really hard thing to do. And you might have various, tools for helping the non-technologists or the non-data scientist out, but they're never going to bring you up to the level of, the skill, experience, and knowledge that, say, someone who has a PhD has, or someone who has a PhD and has been building models for 10 years. You're just not going to get there. So there's lots of technical mistakes to make, which can be disastrous if not properly vetted. And then there's lots of ethical mistakes to make. I mean, there's lots of ways, as we discussed at the top of this call, there's lots of ways of bias getting into your model. But if your citizen data scientist doesn't know about it, doesn't know about the tools for vetting for bias, can't even use the tools anyway because they don't have the training for it, they're going to create discriminatory models in all likelihood. So that sort of citizen data scientist, which is really a way of saying novice or amateur data scientists, can be useful in some way, but it's also really dangerous. And so if an organization is going to pursue that strategy, they're also going to need a big strategy that has to do with creating the proper kinds of training and controls around those people, including having things like data science mentors, AI ethics mentors, et cetera, et cetera. And not just mentors, but also a gatekeeping function. Having the real experts check this thing through to make before deployment. Otherwise, it's disaster.
Sounds like good advice. I just got two further questions.
Mm-hmm.
One that is, I guess, less related to AI, but you've written about blockchain and the ethical questions that are associated with that. And because you'd written about it, I wanted to capture your thoughts, because there will be people who are watching this that are thinking about blockchain and may even work in it. So what are your thoughts there?
I got lots of thoughts about blockchain. I mean, I'll focus on one in particular. I think one of the dangers of blockchain is the language around it, that it's decentralized, that it's it's democratized. It's there's no intermediary, there's no middleman. And all this talk of decentralization makes it sound like this kind of libertarian wonderland where, we're all equals. There's no central government, there's no central bank. It's just the community of people on the chain. But that's an illusion. That's nonsense. It's true that the processing power is distributed. It's true that the storage of data is distributed, but the governance is not, or at least need not be. Typically, it's a small subset of the people involved in a particular, say, blockchain application who have control over how the blockchain operates. So, for instance, rather famously or infamously, Ethereum had a big problem. Someone figured out what I would call a bug in the software, stole, I forgot how many, tens of millions of dollars. And then the people who were running Ethereum, to make a long story short, said, oh shit, we got to fix this. And then there was what's called a hard fork. So instead of having one Ethereum blockchain, we got the new Ethereum and Ethereum Classic. That was a very, and so the people on the new Ethereum, they got their money restored if it was stolen. It's a massive decision to make. It's a really big, hard decision to make. I mean, people seem to think it was hard. There was massive disagreement within the community about what should be done and what shouldn't. But at the end of the day, it fell to a relatively small group of individuals to make the call. So the governance of Ethereum is not decentralized. It's centralized in a relatively small group of blockchain developers who built Ethereum. So one of my main concerns is that people think that because we've got decentralization and then you have things like smart contracts, so we don't, to ensure trust, although it's really what you do in the face of not having any trust. We don't need to think too hard about what governance looks like. We don't need to think too hard about what oversight looks like, because it's a thing, it's a community thing. It's like a, digital kibbutz, but it's not like that at all. Actually, I don't know too much about the operations of a kibbutz, but it's not a communal thing. It is owned and operated by a very small subset of people. So that's one of my biggest concerns about blockchain, is that the way people talk about it is deceiving. Yep.
Very helpful and very topical. We're seeing a lot of focus on that at the moment. Okay, the last question. It's a very much a general open question. Have you got any final advice that you would give, that you would like to share? I just wanted to capture anything else that you might be thinking around AI. First of all, for organizations, but also maybe for data scientists who will be going to work.
I mean, there's, depends on who exactly the audience is. I mean, I think generally that our organizations need to figure out what, responsible AI, trustworthy AI, AI ethics, AI ethical risk program, whatever it is. They need to figure out what that looks like at scale. It's not just, there's in-house data scientists that are building things. you need to get some kind of grip on that, make sure that you're protecting people and, frankly, your brand. It's not just the data scientists in-house, it's procurement. I think that there are Trojan horses being brought into organizations all the time because you've got AI startups who are not doing their due diligence on bias or discriminatory models or on they don't care about black boxes, that often, not always. They're not checking for privacy violations. They're just doing stuff and looking to see what they can sell to enterprise because they want to make a lot of money. So what AI governance has to look like within an organization is it's organizational change. It can't just be this is for your data science team for at least two reasons. One, which I just specified, which is that your HR person, people in HR, people in marketing, people in finance, they're all getting bombarded with emails and pitches by AI vendors who are selling them things, and they don't know the right questions to ask. Even if they do know the right questions to ask, they don't know what the right answers look like. They don't have any means by which or internal process by which they can sort of kick off or kick over the software to some internal data science team to do some kind of vetting. That just doesn't exist. So you have to think about what does AI risk mitigation look like across the enterprise, not just within the models that we build in-house with our data scientists. And then the other thing is that it has to be a cross-functional team. One thing that we haven't touched on too much is that there's lots of decisions that need to be made that should not be left solely in the hands of data scientists. So does this count as a discriminatory impact? I mean, data scientists don't receive a lot of training there. Lawyers, people who specialize in civil rights, ethicists, those are appropriate people to involve in the mix. I mean, there's loads of qualitative decisions like, is this explanation good enough for our stakeholders? That's not the kind of thing that a data scientist specializes in. Is it enough to anonymize the data in order to respect people's privacy, or do we also need to give them some kind of control over their data? That's not a question that data scientists are, if you like, meant to answer or trained to answer. So it requires a cross-functional team. There are quantitative and qualitative decisions that need to be made, and you need to involve the right experts. Now, if you're a data scientist and you want to get, there the thing is, what can we do? I really think this thing has to be top down. I don't think that an AI governance program works unless it's top down, owned by someone in or in very close proximity to the C-suite. So that what data scientists can do, insofar as they're sort of more junior data scientists, is sort of encourage other data scientists, including the people who work above them, to take this stuff seriously. And it works. I mean, many people have come to me, many organizations have come to me as a result of their more junior people pushing for something like AI ethics within their organization. So that sort of stuff does work. So I don't think that, the data scientist, the junior data scientist has to sort of, fight the good fight and just whenever they build a model, they always make sure to do X, Y, and Z. I mean, that's good. Do that. Great. But the bigger, more important battle is getting organizational buy-in, which could include educating other people, raising awareness, that sort of thing.
Very helpful. A lot, and all of the answers that you've given have been very helpful too. Bearing in mind that most of the people who watch this will be going into roles where they're dealing with the things that we've been discussing. So, I really appreciate you doing this, Reid. It's been very good of you to give your time and
yeah, it's my pleasure.
And your knowledge.
Yeah, my pleasure. Great chatting with you.